Hi, I'm Sean Williams. I'm in CS 480, Artificial Intelligence. This is assignment number 2, and we were required to implement the MinMax search algorithm. This is my code that's running. This is the MinMax search. I'm going to do test case 1, txt. I implemented a apply level for the short case. It's actually, it doesn't matter which level you select. I'm going to select 1 for min-max search. The min-max search algorithm does not do alpha beta pruning. Item number 2 does. So this does min-max search. So I'll just do 1. And here you can see that comes back with the board state. I'm going to hit yes to continue. Test case 2. And then apply level of 10. Again, it doesn't matter for this one because it's a really short test case. I'm going to do min-max 1. And again, it comes back pretty quickly. Now I'm going to run test case 3, and I'm going to run it with apply level of 10, and then I'm going to use min-max search number 1. And here, if I let it run, it's going to take a really long time. It probably will not execute successfully. After about 10 seconds, I just cancel it and start again. What I wanted to show is that if I put apply level of 10 and then I use min-max alpha beta search, it executes significantly faster. So I'm going to stop it and start it again. And then we'll apply level of 10, and we'll do 2. And after about 4 or 5 seconds, you will see that it executes. Over here on the right side, you can see that I have separate classes. Most of the classes are here in this game state. And then there's the search classes. I have a separate alpha beta search class and then max search class. And then here in the framework, the only classes that are being used are this heuristic function as well as the min-max heuristic function. And there it is. You can see that it executed. And it said that I lose. So max always goes first. I'm always first. This is min's turn. So no. So here's the code. Basically, the min-max search class has this heuristic class, heuristic function, which can be instantiated from the constructor. That way, you can swap out different heuristic functions. And then it has a previous depth and a current depth and a apply level, which is how deep to go, iterative deepening. It also has these comparators, which allow you to swap in and out how the priority queue pops things off the stack. So if you scroll down to the min-max search, I have a search class, which every time the apply level is reached, it goes back to the next node and searches again through the tree. The search class is the main class, right? It accepts the node. This code right here is where it generates the actions, and then it calls the heuristic, and then it sets the heuristic on the actual node, and then it adds that node to the priority queue. And of course, the heuristic determines the order of the queue. The heuristic, I'll show you that in a second. This is the part that actually loops through each item in the frontier and, and and generates and calls the min and the max value functions. Here's the min value function. It follows the same pattern. The only difference is that it takes map.min right here, map.min, and then it calls. If it reaches the depth level, that means it needs to run the heuristic on it. If it's not at the depth level, then it continues calling max until it gets to the depth level. If a goal state is reached, then this goal process is run, it sets the game state, and then it returns utility value. Last thing I want to show you let me show you this heuristic. The heuristic function is just um, a class that calculates. Sorry, it's a class that's the interface. The min-max heuristic function is a class that actually counts the remaining moves, and then it returns the difference between the, the remaining moves minus the moves taken. So let me jump over here to alpha beta search. Alpha beta search is exactly the same thing. I just copied and pasted the code, and the only difference that I did in alpha beta search is right here. Well, first difference is um, how it's called. The max function is called first. So here, max value is called first, whereas in the min-max search, min is called first. And then the only other thing is this code right here. This is what tracks the alpha and the beta. And the same code here is listed in the max routine. And alpha and beta are declared here as zero. So that's it. Hope you enjoyed this.